Design, assembly, and quality testing of feeder panel. Abstract: to design the feeder panel according to the load and requirement of the consumer, preparing the general arrangement diagram and the wiring diagram. According to the general arrangement, assembling of bus bars, circuit breaker, and MCCB. Also drawing of wire for the control of the panel and for the power to the control circuit. Quality testing for checking for the requirement to be achieved for the consumer. Keywords: designing, assembling, quality testing. Introduction. The feeder panel is used for the distribution of the power for different uses and as per the requirement of consumer. It is also used for the interconnection between the different supply and also synchronism with the diesel generator sets as the backup supply. The feeder panel generally consists of MCCBs for the distributions to the output ranging from 16 amp to 630 amps and the ACPs for the incoming lines and the output ranging from 630 amp to 3200 amp. For controlling of the panel we use the contactors, push buttons, selector switches as per the requirement. With all the controlling and power components for the manipulation of the supply, indication and metering are also installed in the panel, like light bulbs for different applications, and with the voltmeters, ampermeters, MFM, CTs, etc. The following are the general sections of a feeder panel. Incomer section, TR. Bus coupler section, BC. Output section, O/P. In above general sections of the feeder panel, the bus coupler section is been removed or added more as per the application or the number of incoming sections. 2. General overview. The design of the feeder panel starts from the requirements and single line diagram sent from the consumer. The work starts from the making list of the components, designing of the shell of the panel, fabrication, and electrical designing, to be used to meet the requirement of the consumer. After the fabrication is completed as per the design, the assembling of the components is been completed. Component like MCCBs, circuit breakers, meters, indications for phases, R, Y, B, current transformers. The wires are drawn for metering, control circuit, power circuit. After the completion of the assembling of the panel, the quality testing of the panel is done by the Q.C and the panel is dispatched for the installation at the site. 3. Designing. The designing is the first step of the production of the panel. For designing there are some components that are necessary for it. The following are as below. The requirement sent by the receiver of the panel. The single line diagram including incoming line, outgoing line for the applications. The make list for the components to be used. The rating of the I/P lines and the applications. After receiving the above information, we should start the design process as per the requirement sent by the consumer. We, the designer, decide the placement of the bus bar as per the space available for the panel installation and the quantity of the bus bar as per the cost of the production of the panel. The following are the different placements of the bus bar. Overhead bus bar, single tier circuit breaker. Mid bus bar, single tier circuit breaker. Overhead bus bar, double tier circuit breaker. The mid bus bar single tier circuit breaker arrangement is generally used where the space is less required for the installation of the panel, and also where there is an issue of the cost because the quantity of the bus bar is used less. Outer shell of the panel. After deciding the placement of the bus bar according to the usage of the space, the designer designed the outer shell of the panel, and the main part of the outer shell is the box fabricated for the installation of the circuit breaker to be placed and installed in the shell. The dimension of the box is as per the IEC standard. The table show the standard used. Front cable alley, MCCB. Rear cable alley, MCCB. Ampere rating. Dimension of the box, mm*mm. The above tables are of the standard used for the design of the outer shell and the width of the panel. The above dimensions are without any metering and with basic indications like on-off status indication. The dimensions will change and will be increased with addition of the meters, selector switches, and extra indication of status. The MCB box is to be selected as the number of thumbs. The following is the common size to be used. Height of the box is fixed to the 250 mm, but the width will increase as the quantity. If there are two MCBs, the width selected is 300 mm and the width will increase as the quantity like 3 MCBs, the width will be increased to 400 mm. Now if the line of the MCB is increased, the height for 2 line will be 400 mm, 3 line will be 550 mm and 4 line will be 700 mm. The line of the MCB should not be more than 4 line. It is the general rule for the switchboard using MCBs. 2. Selection of the bus bars. As we have decided the location of the bus bar in the panel, we have to select the bus bar as per the requirement and the current capacity of the panel. The bus bars could be of 2 types. I.Copper. 2. Aluminum. Thumb rule. For aluminum 0.8 amp/1 SQmm of bar. For copper 1.6 amp/1 SQmm of bar. Points to be considered while doing sizing calculation. Adequate minimum required clearance between 2 phases and phase to earth. Selection of adequate bus bar insulator standoff. Bolting arrangement for continuous bus bar connections. Thermal effects on bus bar and insulator standoffs under normal and fault condition. Electrodynamic forces applied to bus bar and insulator standoff under fault conditions. Avoidance of mechanical resonance under normal operating and fault conditions. Temperature rise. Maximum permissible temperature rise for bolt connected devices including bus bars. Material and dielectric medium. Maximum permissible temperature. Bolted connection. Bare copper alloy, bare aluminum alloy. In air. 90 OC. In SF6. 115 OC. In oil. 100 OC. Consider ambient temperature of 40 OC. Source reference IEC 62271-1. The general equations that is used for the sizing. Coefficient factors K. The total K factor derived from 6 K factors which is listed below. K equals K1, K2, K3, K4, K5 asterisk K6. K1 equals function of the no of bars per phase and their space. K2 equals corresponds to the surface finish of the bus bars. K3 equals function of the mounting arrangement. K4 equals function of the installed location. K5 equals function of any artificial ventilation. K6 equals function of the type of current. Rated current I equals total K factor asterisk main formula. Bus bar clearances. Voltage, V. Phase to phase clearance, mm. Phase to earth clearance, mm. Requirement of the consumer. Breaker size needed 1250 amp ACB. Transformer secondary full load current equals 1066.72 amp. According to thumb rule. For copper 1.6 amp/1 SQmm of bar. For area 800 SQ.mm 80 asterisk 10 mm the current carrying capacity will be 1280 amp. So, according to formula as per IEC 62271-1. K equals K1, K2, K3, K4, K5 asterisk K6. K equals 1110.81 asterisk 1. Equals 0.8. Rated current I equals total K factor asterisk main formula. 1250 amp equals 0.8 asterisk main formula. Main formula derived value will be equals 1562.5 amp. Rated current equals 0.8 asterisk 1562.5. Equals 1250 amp. To carry the current of 1066.72 amp 1 runner of 80 asterisk 10 mm of copper is enough. 3. Wiring of the panel. The feeder panel consists of 2 type of wiring as follows. Control wiring. Power wiring. The wiring is been designed as per the requirement of the consumer. The control wiring includes the indication and metering of the panel. The bus coupler wiring is also important and the auto manual operation selector wiring is a part of the control wiring. The power wiring includes the wiring of the control feeder for the power. The wires are generally taken from the bus bar. Figure bus coupler wiring diagram. Figure bus bar arrangement for bus coupler. The above figure shows the wiring diagram of the bus coupler. It is used to satisfy the conditions of interlocking. The below table shows the interlocking conditions, auto/manual, for the above shown bus coupler. The auto manual indicates the breaker would be operated by the push buttons in case of manual operations, and in case of auto operation the breaker operates by the supply to the breaker directly, and if the selector switch is on the auto and the breaker should not operate by the push buttons. This is the last step for the designing. After this step the fabricators start the fabrication work as per the approved drawing of the outbox, shell. 4. Assembly. Installation of the equipment in the shell finished with powder coating and ready to be assembled. The breakers are been installed in two parts, the cradle case and the contacts box. When the installation of the ACB and MCCB is been completed, the bus bar are been sent for the making as per the sign. The fabrication of the bus bar is been done in some steps. The following steps shows the steps of the bus bar fabrication. Selecting the size of bus bar as per the specifications of the design. 2. Measuring the length of the bus bar and marking the bends. 3. Making any one bus bar for checking the accessibility in the bus duct and to the ACB or MCCB. 4. Approving the bus bar by the designer as a sample if not chan gain bend and change in length if any changes needed from the designed bus bar. V. Approved from the designer making of the same sets for all three phases as per the approved sample. 6. Fitting the bus bar in the panel with the help of supporters and spacers as the specified area. 7. Tighten the faceplate and connect bus bar sections with each other, connecting the bus couplers with the other two sides of the bus coupler. Checking the tightness of all the parts of the bus bar connected with the bolt and nut. Wiring. The wiring is the most important part of the panel because the controlling of the panel and some low power transmission is also done through wire. The control wiring is usually done with 2.5 SQMM copper wire or the 1.5 SQMM copper wire. We have to draw the wire as per the design diagram in the panel and select the wire as specified by the designer. The contactors are used for the interlocking the panel in auto or manual mode. The contacts of the ACB are being also connected as per the wiring diagram. The connection of the CTs is been done to the meter for the metering of the panel. There are some extra accessories to the ACB and MCCB from its already included parts. Some of the parts are mentioned below. Secondary isolating contact and electrical position indicator and cradle secondary isolating contact block. 2. Voltmetric releases for U-Power ACB. 3. Closing coil for U-Power ACB. 4. Mechanical type door interlock. V. Operation counter for U-Power ACB. There are also some supplementary modules used to provide addition protection to basic protection and control circuit are listed below. ZSI module. PS module. AO module. DIO module. Relay module. TCS module. L module. Ref module. The earthing strip is been installed at the bottom of panel made of copper. Generally the green wire is been connected between the door and the frame of panel as earthing. Quality testing. The last process of the panel fabrication is to check the panel meets the requirement of the consumer. There are some tests listed below for checking the quality of the panel after the process of assembly is been completed. Verification of bill of material as per approved GA drawing. Overall dimensions as per approved GA drawing. Tightness of bus bar joints and pull test off crimping of lugs, on random basis. Provision of partitions and shrouds and effectiveness of safety shutters. Electrical clearances and creepage distance. Earth continuity/earthing system. Operational test as per scheme drawing. Wiring check as per scheme drawing. Phase sequence/polarity check. Overall appearance and surface finish. Verticality of panels. Waviness of doors, etc. Neatness of wiring. Accessibility and adequacy of space for external cabling/wiring termination. Insulation resistance. High voltage test. Dry film thickness test. CT polarity test. Busbar joint resistance test. Temperature rise test. Testing of metering and indication. The supply is given to the control indication and metering circuit through MCB board, the glowing off lamp, voltmeter, ampere meter, and setting of MF meters by installing the CT ratio in the meter. Testing of breaker operation. The supply is given to the breaker and the operation off opening and closing was performed multiple times. The breaker should perform the tripping and connecting operation successfully without any problem. At the time of trip condition the current should be 0 and in the connected condition rated current must be noted. Testing of interlocking condition. The panel is given supply and by selecting the manual mode the on-off condition of the breaker would be checked as the table. The condition should be satisfy in any mode. The breaker in a interlock condition should not be operated, like if TR1 is in off condition and the interlock condition is satisfied, then the TR1 should not be turned on in any mode. Contact resistance test. This test is performed by the contact resistance kit. The kit has an auto transformer and a resistance meter like measure to get the resistance between the contacts of a busbar with another contact of the busbar with the faceplate in the connection between two contact. The resistance should not be more than 0.2 micro-ohm. Fig contact resistance meter. High voltage test. This test also requires a HV testing kit. The supply of 1.5 kV to 2.5 kV AC 50 Hz is given for 10 seconds between any terminal and mounting plate. Fig high voltage tester. Temperature rise test / short circuit test. This test requires auto transformer, low voltage high current transformer, busbar assembly, busbar's Hort link. The mentioned apparatus are been connected to the panel. The main busbar is been short from one end by the BB short link and another is been connected to the LVHI transformer and given supply for 4 hours. During this test it is essential to keep the breaker at the SC end to be connect and other breaker to be disconnected. The temperature of busbar should not exceed 90 OC at any point of time as specified in the IEC standards. The below table shows the reading of temperature rise test. Time. First connection. ACB top. ACB bottom. HBB end. The maximum temperature reach after 4 hours is 74.6 OC and is under 90 OC. The ambient temperature was 30 OC. Conclusion. This paper has described the process of building feeder panel from designing of the panel to the testing of panel. This paper also includes the designing parameters to be considered while designing of any rating of feeder panel. We can build any rating of feeder panel with help of above given data.